Então, nós agora convidamos Steven Henry Rader, gerente adjunto do Centro de Excelência em Inovação Colaborativa da NASA, para apresentar uma palestra sobre desafios e competições de ideias na NASA, a busca da inovação via crowdsourcing. Steven é engenheiro mecânico formado pela Rice University e trabalha há 25 anos no Johnson Space Center, em Houston, Texas, tendo participado de projetos do ônibus espacial e da Estação Espacial Internacional. Lembramos a todos que essa palestra será em inglês, sem tradução simultânea, e que a mesma está sendo transmitida diretamente do Johnson Space Center em Houston. Hello, Mr. Rader.
Hello.
In name of the University of São Paulo and Escola Politécnica, we would like to thank you and NASA's Johnson Space Center for your speech in this seminar. Thank you very much.
Okay, thank you very much, and thank you for inviting me to speak today. I am going to present a package that I normally present at NASA to our employees. We are still educating our employee base on what crowdsourcing is and how we can use it, but I'll also show many examples of how we have used crowdsourcing today. We'll just jump in here. I know you guys are advancing the slides as well. We usually start talking to our base on something that I'm sure you're already familiar with, which is open innovation. And open innovation ultimately is getting outside of our own groups to find ideas and concepts and innovations that we can't normally access. And we do that through crowdsourcing, which is this private online distributed problem-solving production model. In particular, we think that this is a great way to access expertise. And the way we show this for our workforce is to say, you know, really, while we at NASA have some of the experts in the world on certain areas, Bill Joy noted that some of the bright people in the world don't work for you, no matter who you are, and that is especially true for NASA. And so, if you notice here, the curve shows general expertise and capability along the bottom, and number of people along the left. And we at NASA see ourselves as one of those advanced organizations where we actually have some of the expertise. But the reality, when you look at the actual crowd, if you click one, is that our organization, I think you missed some of the animation. The reality, it's okay, stay there, is we have actually a much smaller number than that, and what we want to access are all of those people to the right. So those are the people with the high value expertise that are smarter than on a given topic in a given area. Let's go to the next slide. What we focus on in my office particularly is accessing crowd through curated communities. Curated communities you're probably familiar with are communities like freelancer.com, TopCoder, which is 1.1 million software developers and data scientists, Tomble, which deals with video and has a bunch of expertise around that, and then several communities that deal with more problem solving, like a 9 Sigma or Incentive, where there's really crowds of hundreds of thousands to even millions of people that can be accessed to solve really hard problems. So we use these communities, next slide, mainly because they have the resources and tools for these members. They know how to attract them to join. They know how to incentivize them to do work of some sort. They know how to build community to keep these people coming back. They also have the agreements set up so that the users are protected for any intellectual property that they generate. And for a consumer, like a company, and I know you guys were talking about crowd testing in the last presentation, for companies that use these kinds of services, they provide the handling of the intellectual property. And so any sort of transfer or licensing that has to happen. And that is a very good capability for us to have within a company, because it's a very difficult thing to handle on our own. Next chart. I get a lot of questions within our community of who are the crowd and why do we want to access them, because a lot of people don't really appreciate the capability that the crowd has. And what I tell them is on the slide. The crowd is made up of almost everyone. There are mathematicians, researchers, technicians, full-time, part-time employed people, and really all of those people can bring something different. And for problem solving in particular, those crowds can have the one person that can solve your problem in a way that no one else can. And what we find for those people is they not only have the domain expertise for the problem, but they have some sort of adjacent or complementary expertise that brings something new into that. And then they'll also have some applicable experience. And what we find with a lot of these crowds is they have passion. The members have a passion to try to solve problems or to write algorithms or software, and we can really tap into that passion to solve problems. So if we take somebody like Topcoder, and we look at Topcoder, that's 1.1 million software developers. That's about 6% of all software developers in the world in one community. And we can actually tap into that because we have a much smaller group. We have a group of maybe 3,000 software developers just within NASA. And so we can tap into those experts that are much smarter than us or more capable than us in this particular area. And we do that, if you go to the next chart, through contests, through challenges. And that actually enables us to access that sliver of folks that are actually smarter than the folks we have in-house. The reason we do this through companies that have crowds is that they can handle all aspects of developing the challenge. So they can formulate the challenge, they can design it, they can execute it, and then they can provide solution filtering, which, if you do a large contest, can be very valuable. We just did the Space Hoop Challenge, which actually garnered 20,000 registrants and 5,000 submissions. We at NASA did not want to have to go through 5,000 submissions, and so the community in that case was HeroX, and that company went through and filtered out really almost all down to 87 different submissions, and those final 87 they handed to us, and we did the final judging of those high quality submissions. So that can be a very valuable thing when you're doing a large crowdsourced challenge. And then they help you pick the winners, like I say, and get the IP. Next chart. I think you guys know this, but I usually have to really emphasize to our community within NASA that these tools are not new and they are mainstream in industry. And that is why there are so many of these companies, as you can see on the slide, just a snapshot of the number of communities and companies that have been formed around this industry and the number of mainstream companies that are using these services to augment their research and development and production. If you go to the next slide, I'll talk a little bit about who we are. Our Center of Excellence for Collaborative Innovation here at NASA was established in 2011 at the request of the U.S. government's White House Office of Science and Technology Policy. It just so happened that a couple of our managers were really piloting and exploring how this mechanism was impacting the industry and the positive things that were happening. And after that, that set of pilots and really looking at that, we determined that this is really a value. And about that same time, the White House came and said, we see value there as well, but nobody else in the government is doing that. And so, since you are already doing that, can you actually establish the Center of Excellence, and from that, go and help not just NASA start using these tools, but all federal agencies within the U.S. government. And so that's what we do. We're the NASA Tournament Lab, in there. The NASA Tournament Lab itself is our public-facing brand, and so that's how you would see us on the internet. Represented in various challenges on these platforms. And as you can see on this chart, this is our toolkit. Not the previous chart. Not it. No, back. There we go. This is our toolkit. It is a set of contracts with about 13 or 14 different crowdsourcing communities. Some of these you may be familiar with, some of you may not be familiar with others, but these are actually some of the cream of the crop worldwide in communities that do the things that we at NASA need done. And I'll talk through each of these areas in a little bit different way. You can see on the right of the noise platform, that's the NASA Open Innovation Services contract. That has 10 vendors, including Topcoder, Incentive, HeroX, and you can see the list there. And we use that contract to do the bulk of our larger contests. We also have a NASA work platform that I'll talk at the end about, which is our internal crowdsourcing, which is how we tap into our employee base here at NASA. Yet to provide some of our technology search, we partner with Harvard and Brigham-Young at Harvard Business School on research in this area, so we've been with them for a long time now, and they help us understand the mechanisms. And then we also have found some very inexpensive ways to leverage crowdsourcing that we have on tap to help get some of our projects that don't have a lot of funding started in this area. Next chart. The first area I want to talk about that we use crowdsourcing for is this problem solving or finding innovation in an area. Next chart. And in this area, we have a number of vendors or crowds that are really good at this. In Incentive, we've actually worked with for about 5 years, so I'll talk a lot about those examples. Over the last 2 years, we brought the rest of these folks on, the 9 Sigma, OpenIDEO, HeroX, and they've done a lot of challenges with us as well now. Next chart. The main thing about this, you can see my animation didn't come through, it's okay. The key to these problem-solving communities is that unlike a Topcoder community where it's a million software developers that have all a similar expertise, in these communities like 9 Sigma or Incentive or HeroX, it's a very diverse crowd. And that diversity is really the secret behind the innovation. And in fact, MIT did a study where they looked at Incentive's successes. So Incentive has a success rate of between 60 and 80% successes, which means that the majority of the time that a company brings in a problem that is not solved, that they have not been able to solve for years, that most of the time Incentive was able to solve that. When they looked across all of those successful solutions, what they found in the study was that almost 70% of the time, the successful solutions came from someone outside of the domain of the challenge owner. So if you were a chemistry lab working on a chemistry problem, then if you put that out as a challenge, 70% of the time, the person that was going to be solving that challenge was not going to be a chemist, or they were going to be a chemist that actually works in another field. And that is a really important thing in the way industry has viewed this, and why they've really changed the way they do R&D to leverage these contests. Not to replace the labs of chemists or biochemists or engineers, but rather to augment the progress by popping out, doing a challenge, and then going and solving the problem, and then developing that for their product. A good case study, if you go to the next chart, is Roche Diagnostics. So Roche Diagnostics is a large multi-billion-dollar pharmaceutical company. This is a case study done out of London Business School. And Roche Diagnostics basically wanted to try Incentive. Now this was several years ago when Incentive was about 150 to 200,000 members. Roche Diagnostics, like I said, wanted to try this mechanism. So they actually took their whole company and surveyed to find some of their hardest problems that they had been working for a long time and not been able to solve. And they found one where it was an automated diagnostic machine that as the sample came in, they needed to very precisely measure the quantity and quality of that sample. And they worked for 15 years to try to understand that mechanism. And they had not been able to solve it. So they took that problem to Incentive. They ran a $20,000 challenge on that platform about 2 months. And not only did they solve the problem, that solution actually came independently from 2 different solvers, so it existed in the marketplace. But moreover, when they looked at all of the submissions, they actually saw everything they had tried over 15 years replicated in the challenge. So if you think about that for a second, that is replicating 15 years of R&D in 60 days for a $20,000 prize. This is why industry has really changed the way they're doing R&D, and they're tapping into this innovation mechanism. And that's why we're doing it. So if you go to the next chart, you'll see that we actually did this with the Mars Balance Mass Challenge. This was where on our spacecraft, as we come into the Mars atmosphere, we actually can't use jets and we can't use aero surfaces because of the undefined atmosphere that we're going through and the density that we don't really understand. And so what we do in that case is we actually throw off ballasts to adjust the trajectory as that spacecraft comes into the atmosphere. Now, if you know anything about going to Mars, it's very, very expensive to take even a gram of mass all the way to Mars. And we were taking kilograms of mass all the way to Mars just to throw it overboard in case we needed it. And there's been a big push for a long time to find something that we could do with that mass that would give us added value. And so we put that out as a challenge. It would cost us about $50,000. The prize was $25,000. This was on incentive. We got a bunch of different ideas, but the winning idea was actually to use barium tracers, to use trace elements in that mass that we eject, and then use one of our orbiting spacecraft to actually monitor the atmosphere as that trace element dissolved in the atmosphere, and we would get some useful measurements. The winner of this has actually gone on to brief the Mars team, and they're looking at using that design in future missions. But the interesting thing is this guy was from a very, very small village, 800 people, and he had a marine science as his background. So somebody that we never would have reached out to individually ended up being a very valuable asset. And he has actually gone on to solve several other challenges on NSM, so it's kind of one of these super solver guys. If you look at Vectron measurement, this was where we have our inflatable space modules, and it's very difficult to, in the testing, actually measure the strain in those materials under the conditions that we needed to use. And so this is where we weren't trying to look for a solution in space, but rather in the development phases. And we ended up getting about 72 submissions from 19 different countries. And if you notice the quote here from the challenge owner, I think you can kind of get a feel. They actually awarded 3 different awards for similar solutions, but they said the solutions were so simple and elegant, how could they not have thought of it themselves? And we see that over and over in innovation, is people are closed to these ideas that in hindsight, when they find them very intuitive. A great example of that on NSF that they use as a case study is with a potato chip maker. Came to them and said, we're looking for a better way to get grease off of our potato chips. And so they took that to Incentive. Incentive reframed that question as, how do you get a viscous fluid off of a delicate wafer? And by rephrasing it that way, they actually expanded the ability to for folks to actually understand that. So they didn't just get food scientists, they got people that were working on electronic wafers in different fields to come and try to work on that problem. And it ended up that the solution from that was to vibrate the actual oil on the chip using natural frequency to actually vibrate the oil off the chip. Now, the solution provider on that was a musician, a violinist. But if you think about that for a second, mechanical engineers are experts on natural frequency, and the food industry has many, many mechanical engineers, and yet they were never able to tap into that kind of solution. So that's kind of the power of these platforms. I know we don't have a lot of time, so I'm going to have just a few examples, but the next area is algorithms and software, where we really found a lot of power, and I saw from your last presentation, I know that you're heavily aware of this. Our main platforms that we use for this are Topcoder and Kaggle, but some of the other platforms will do some software, and I'll go more. Next chart. The case study I use with our people at NASA to demonstrate this is a study that the Harvard Business School did to try to understand, is it better to have expert software developers or the crowd work on something? And so they did a test where they took a megablast algorithm, which the NIH, the National Institutes of Health, uses. this is kind of their workhorse. It was developed for about $2 million US over several years. It runs in 4.3 hours at an accuracy of 0.72. But if you go to the next slide, you can see, oh, so the animation did not complete. Go back. It's a shame that the animation did not work. Back, because you won't be able to see the graph here. They actually hired 2 postdocs to actually do the work improving this algorithm, and they were able to, for $120,000 over 1 year, to actually increase the performance to 47 minutes and 0.77 accuracy. They then did a 2-week challenge for $6,000 prize on Topcoder, and were able to get that time down to 16 seconds and increase the accuracy of 0.8. Now, it's unfortunate you can't see this graph, because if you could, maybe you can see it. If you switch it to ours, you can see it. I don't know if you can easily do that. Is it on there? Okay. So if you're looking at that graph, what you see is the Topcoder solution, that big red dot, is actually 2 to 3 orders of magnitude better improvement, because that's a logarithmic scale. But the fascinating thing for algorithm folks is that cluster of red dots to the right and slightly down, that is all of the losers. And all of those losers had better solutions by 1 to 2 orders of magnitude than the crowd students. If you click one more time, go ahead. We actually found 89 different approaches, and in the algorithm world, this is a significant feature, because those 89 different approaches allow researchers to actually take those algorithm results and that contest results and do even more with that algorithm. So, at NASA, we've done this with Asteroid Data Hunter. On the next slide. Asteroid Data Hunter was a 15% improvement over the Sky in the Sky survey, which was the standard that we use for detecting asteroids. Asteroids are very hard to detect, and so this was a really nice feature. Notice it cost us about $190,000, but that included developing a multi-platform downloadable app for amateur astronomers to use this algorithm. So it's actually a software development and algorithm challenge that we did there. On the next chart, you see we've used this on Robonaut to improve some of our vision algorithms, our machine vision. And in fact, on this last one, we spent $60,000 to do a tool vision recognition improvement algorithm for different lighting conditions. And when we talked to the challenge owner afterwards, they said that challenge saved them over $500,000 in development costs. We also use this on the next slide with software development. And in software development, in the life cycle, one of the things, and our primary vendor for that is Topcoder, they split software development into lots of smaller challenges. And by doing that, they access the specialty subcategory, the specialty sub-experts within their million-person community to give us some of the best user interface work, some of the best architecture work, and it's been very effective for us. And in fact, on the next chart, you can see we actually have the food intake tracker, which was totally developed on Topcoder by the crowd, and that is actually now flying on the International Space Station and used to track the crew food. If you look at the next slide, you can see the lunar mapping and modeling portal. This one actually stitches together imagery. The big thing here is we went from 19 hours of processing down to 3 hours, not by an algorithm improvement, but by an architecture improvement. And that's a huge thing if you're actually talking about improving software. Moving on to the next kind of challenge is micro-purchase. This is where we actually use a government credit card. So normally it takes us several months to actually establish a contract with a vendor, but we actually can use this government purchase card for anything less than $3,500. So if you go to the next chart, we actually use the first one of these with GrabCAD, which is a community of over 3 million mechanical engineers and designers. And he actually said, we can do a challenge for $3,000. And so we made that purchase. and they actually put together a challenge for us that I used with the in-space manufacturing folks, the people that have the 3D printer on Space Station, and they wanted to see if we could get designs for Space Station handrail planks, things that we use for the crew to actually attach a laptop or equipment to a handrail on Space Station. And it's kind of a tricky design, but we did a 30-day challenge and received 492 submissions. And in fact, it looked a little bit more if you go to the next chart. So you can see just the diversity of designs that we got there. If you go to the next chart, what I like to tell our folks is, normally, and again, you're missing the animation here, but the red box would be what we normally do. We would normally pay to have our internal team do 3 designs, so there's 3 red dots. And that would cost us probably around $3,000 to do that. But for that same $3,000, we can run a crowd challenge on CrowdCAD and get this wide variety of entries, and most of them are not going to be as good as the ones our in-house folks can do. But if you notice the blue dots, some are better, and by that we can actually get better performing mechanical design through some of these mechanisms. After we did some of these, and we've gone on to do several others with the experiment attached system here, again, we've got 50 submissions from 23 countries in 30 days for a $3,000 prize. It's been a very effective mechanism for us that we're starting to use more and more. We actually went to Freelancer after this because they actually have a very inexpensive platform for running challenges, and I ran a pilot to see what we could do. Go to the next chart. We did CAD modeling. I got about $14,000 worth of CAD work, about 14 CAD projects, photorealistic CAD projects done for $1,100. Just an amazing capability there. And they do challenges as a way to build the members' portfolio. So they're not doing it for the profit, they're doing it actually as a service to their members. And it's a great way for NASA to connect with a lot of people. Going to the next chart, you can see we use this for graphics, which we've gotten a lot of really great graphics for very little. Go to the next chart. We actually did a user interface challenge for a prototype concept for a smartwatch that the astronauts could use on Space Station for timeline, costume warning, and comm status. And we had a really great design. We did a $1,500 prize. You can see we got 245 submissions. The experts that won this were actually specialists in user interface design, gave us a beautiful design, and afterwards, Freelancer said, we can actually build that for you. And I said, well, I can't really afford to do a whole software development effort, so if you go to the next chart, they actually said, no, we can do that, and they for $3,000, they had one of their members build a prototype fully functional software with a data emulator for $3,000. Now, I tell our folks, we're not going to develop space-like code using this mechanism, but a lot of times to do a quick and dirty prototype, this is a great way to get that done, and it's a great way to engage the public in doing it, because a lot of people want to actually be engaged in what NASA's doing. Next chart. The last little bit here, and I know I'm right about out of time, is the NASA at Work community. We try to tap into some of those experts within our own community. So next chart, you can see we actually have a very simple way for our projects to use for free. They can post a challenge on this platform and it goes to all the employee base. We make it very simple, and we take care of all the awarding prizes and all of the mechanisms. If you go to the next chart, you can see that's been growing over time. We typically only have 2 to 4 challenges at any one time, so we don't overload the crowd. But we have about 19,000 people on that, and it ends up being one of the best ways to do enterprise knowledge sharing. We have 10 different centers at NASA, all working on different things, and a lot of times it's very difficult for people to understand what other people are working on and what might apply to them. And so that's been a very handy thing. If you go to the next chart, you see an example of that. We had a project trying to actually determine urine volume in microgravity. They were about to go spend about $1.5 million on some development work. They did a NASA Work challenge and found another lab that had a working prototype of what they needed literally 300 meters away in another building. So a really great way to find out what else is going on. Next chart, you can see the same thing when we were studying thorium uses versus uranium. We actually found through this challenge, one of our Apollo older engineers actually had a study that was worth many thousands of dollars that he was able to pull out of his file cabinet that no one knew we even did. So again, a really great way to find things that we don't know are out there. Next chart just kind of summarizes our history to date. We've done 266 challenges. About half of those are internal. The rest are on these external platforms. You can see there's the diversity of software, algorithms, ideation, graphics, even some video challenges in there. Next chart. This is, I think, my last chart. This is what I tell our team members. I say, this is your menu of options. You can actually get a challenge done for free on NASA at Work and leverage that. If you have a little bit more money, you can run a freelance or a GraphPad challenge. I didn't talk about yet, too, because it's not really crowdsourcing, but it is a text search capability we have. And then you can do a really powerful challenge on our NASA Open Innovation Services or noise contract to do either algorithms or problem solving. And those prices start to get higher. And with that, I'm done. And happy to engage in questions.